Okay, now let's say like we are given a continuous joint density whereby x can take on the values between 0 and 1, and y can take the values between 0 and 2. And remember, this is like a continuous case. So now let's say like we're looking for the expected value of x, and now from the formula we know that we integrate through all possible values of x, and we multiply x by the marginal density of x, and we have to integrate that. But now realize that we have like a joint density of that. So from here we must find like the marginal density of x, and the only way we can do that is like we have to integrate through all possible values of y. So let's find the marginal density of x. This will just be, we integrate through all possible values of y, we integrate the joint density, and we integrate all possible values of y, and y is between the interval 0 and 2. So what this means is like we have the integral from 0 to 2 of 3 over 2 x squared y dy, and now we have to like integrate that with respect to y. Now since this is a constant, we can take it outside. Since we are integrating with respect to y, then we'll have something like this, and then the integral of y is just gonna be y squared over 2, and remember we're integrating that from 0 to 2, and remember we still have the constant outside, 3x squared over 2. Now we substitute in the boundaries here. We're just gonna have y squared, where we substitute 2 is just gonna be 4 over 2, and then we subtract 0 squared, which is just gonna be 0 over 2, and then from then we multiply that with 3x squared, then we divide by 2. Then from here 4 over 2 is just 2, minus 0 over 2, which is just 0, so we're gonna have just 2. 2 minus 0 is 2. Then we multiply that with 3x squared over 2. We're just going to have 3x squared. Now that means like the marginal density of x is just going to be 3x squared. And now remember, we have to show that x can take on the values between 0 and 1. Now from here we can further find the expected value of x, since we're just going to integrate through all possible values of x, and we say x multiplied by the density function of x, which is just going to be 3x squared dx. And from then we can further simplify that. We'll have 3x cubed dx, and now we can find the integral of that. We can take the constant outside and integrate x cubed, which is just going to be x to the 4th over 4, and we substitute the boundaries in. So we're going to have 3 into 1 to the 4th is 1, so we have 1 over 4, and 0 to the 4th is just 0, and we have something like this. Then we're just going to have the expected value of x will be 3 over 4. So that's how we'll find like the expected value of x. Now what about like we try to find the expected value of y? Now it's just a similar process here. We're just going to find the marginal density of y. And how do we find the marginal density of y? We're just going to integrate the joint density through all possible values of x, and x can take on the values from 0 to 1, and that will be the marginal density of y. So we're going to find the marginal density of y to be this is our joint density, 3 over 2x squared y. And now since we're looking for the marginal density of y, we're just going to integrate through all possible values of x. So now we can take the constant outside. Now the constant this time is just going to be 3 over 2 times y. So we can take 3 over 2y outside the integral. Then we remain with x squared dx. And then from then we just integrate that. We're going to have 3 over 2y, and the integral of that will be x to the 3rd over 3, and then we integrate that from 0 to 1. And now we just plug in the boundaries here. We're just going to have 3 over 2y into 1 cubed, it's 1, and we divide that by 3, and 0 cubed is 0, and we divide that by 3, and then we just further simplify that. We're just going to have 1 over 3 minus 0, which is just 1 over 3, and then multiply that with 2/3, 3 over 2 of y, then we're just going to have 1 over 2y. So that means like the marginal density of y will just be half y. And now don't forget to show that y can take on the values from 0 to 2. This is where that density is valid. So now since we're looking for the expected value of y, it's just a similar process. We integrate through all possible values of y, and we say y multiplied by the marginal density of y, which is just half y. So we multiply that with half y, and then dy, and that's just going to be the integral of from 0 to 2. Y times half y is just going to be half y squared, and we can take the half outside, then you just have y squared like this, dy. And if we do the integration there, we're going to have half, and the integral of y squared is just going to be y to the 3rd over 3, and we're going to plug in the boundaries thing. Now if we plug in the boundaries, 2 cubed, it's 8. So we're just going to have half into 8 over 3 minus 0 cubed is 0, and then 0 divided by 3 is just going to be 0. So we're basically going to end up with 4 over 3. So now the expected value of y is 4 over 3, and the expected value of x is 3 over 4. Let's go to the joint density, and let's look at the boundaries here. Notice that the boundaries here, x can take on the values from 0 to 1. So we expect the expected value of x to be between that interval, and we expect the expected value of y to be less than 2, somewhere between 0 and 2. That's why you see the expected value of x is between those boundaries there. And so it can never happen that you'll find the expected value to be outside the interval of which the random variable can take on. So now let's say now we want to find the expected value of 2xy. So now this will be the same as 2, the expected value of xy. So it has never been stated whether they are independent or not. So now the expected value of xy will just be the integral from all x and y values. So let's start with x. X can take on from the values from 0 to 1, and y can take on the values from 0 to 2. And now, since we're looking for the expected value of both x and y, then we have to multiply the joint density by x and y, and we have our joint density, which is just 3 over 2x squared y, and then we'll show that it's dx dy. And we'll just find the integral from there. So we have 2, the integral, the double integral of that, and then let's just further simplify this. So we're just going to have 3 over 2 x to the third when we multiply x with x squared, and we're just going to have y by y, which is just going to give us y squared dx dy. So now from here, we can take the constant outside both integrals. So we can take 3 over 2 outside both integrals, and 3 over 2 multiplied by 2 is just going to be 3. So we're just going to have something like this. And then we have x cubed y squared dx dy. Now the first integral here is with respect to x, so that means y squared is a constant. So we're gonna have the integral of x cubed being x to the 4th over 4. Remember, y squared is a constant for the first integral here, and x can take on the values from 0 to 1 dy. Then we plug in 1 to the 4th is 1, so we're just gonna have 3 0 to 2 of y squared into 1 to the 4th is 1, and we divide that with 4, and minus 0 to the 4th is just 0. Divide that with 4 is just going to give us 0. So we have something like this. So we'll end up with 3, the integral from 0 to 2 of 1 over 4 y squared dy. And we can also take the 1 over 4 outside, so we'll have 3 over 4. And then we integrate y squared, we're going to have y to the third over 3. And then y can be is between the interval from 0 to 2. So now we have 2 cubed, which is 8. We have 3 over 4 and 8 over 3 minus 0 cubed over 3 is just going to be 0. So we basically end up with 3 over 4 multiplied by 8 over 3. And the 3's will cancel, and then we'll have 8 over 4. So we end up with with the expected value of 2xy being 2. So from this, we already know that from this we can say that the expected value of xy is just 1. Now the question comes and says, x and y independent? X and y independent. Okay, now let's see the expected value of x. We calculated the expected value of x to be 3 over 4, and we calculated the expected value of y to be 4 over 3. So now we have the expected value of x being 3 over 4, the expected value of y being 4 over 3, and now the expected value of x multiplied by the expected value of y is just going to be 3 over 4 multiplied by 4 over 3, which if you do the calculation, you're going to find it's 1. And this is the same as the expected value of xy, because the expected value of 2xy is just going to be 2, the expected value of xy, which we calculated to be 2. So that means, like, yes, x and y are independent, and the reason will be that e of the expected value of x multiplied by the expected value of y will result in the expected value of xy. So that's how you can know that two random variables are independent. So now let's say like we're looking for the variance of x. So from the formula we know that the variance can be calculated by the expected value of x squared minus the square of the whole expectation, which we have something like this. This one we already calculated. Now we need to go and calculate this. As similar to the discrete case, here we're just going to have a continuous case. Expected value of x squared is just going to be the integral of all x values which we remember x can take on the values from 0 to 1. And now instead of multiplying the density with x, we're going to multiply the density with x squared. So that's because we have x squared now. So if you recall, if we go back, here we have like the marginal density of x, which is just going to be 3x squared between 0 and 1. So we have x squared multiplied by 3x squared dx. And then from here, we can do the algebra here, multiply in, and then we have 3x to the fourth dx. So that means like we can take the 3 outside and then have something like this, and then we integrate that, and we're going to have 3. The integral of x to the fourth is just going to be x to the 5 and divide by 5, and we integrate that from 0 to 1. And then we're just going to have 3. 1 to the 5, it's 1. So you divide that with 5. And 0 to the 5 is 0. And you divide with 5, you're just going to have 0. So we end up with the variance. This is just the square of that expectation, the expected value of x squared. So now we'll have a variance of x being the expected value of x squared minus the expected value squared. So we have something like this. So now we recall that the expected value of x is just going to be 3 over 4, and we have to square that. From the previous calculations, we calculated the expected value. Now the expected value of x squared is just going to be 3 over 5, which is just what we calculated here. So now punching that in, 3 over 5 minus the square of 3 over 4 is just going to give us 3 over 80. And now in multiple choice questions, you realize that it's in decimal places, and usually it's 4 decimal places. So you're just going to have 0.0375, and that's just the variance of x. And now if you have the variance of x, how will you get the standard deviation? So the standard deviation, so now the standard deviation, let me just quickly go and show you this. This is the variance of x, and so this will be like a standard deviation of x. So if you look at this, the standard deviation will just be the square root of the variance of x. The standard deviation will just be the square root of the variance. So now we just take the square root of 3 over 80. Now we take the square root of 3 over 80, and if we do that, we get our standard deviation to be 0.1936 to 4 decimal places, remember. So that's how you can like deal with continuous random variables, even in a joint case. So thanks for watching. Don't forget to share and subscribe.